some backdoor or vulnerability inside a running hypervisor, then this stuff, like starting root of trust or dynamic root of trust, will not help. So you see the situation when we have original MBR. For example, it is controlled by TPM module, so we are sure that the MBR is intact and all the boot process is good. But if we have some vulnerabilities in management domain and, for example, in Xen hypervisor, then we can escape from one of the Xen hypervisor guests to its management domain, and then from management domain obtain the privileges of the hypervisor. Or we can escape directly to the Xen hypervisor if we have some really interesting vulnerabilities inside. For example, if we have some hypercall handler in Xen, which is vulnerable to some buffer overflow, let's see. Then we can install a Bluepill right from the VM2 domain, as shown in the picture. So again, static root of trust and dynamic root of trust does not protect from this type of attacks. We presented a talk at Black Hat this year. The talk was done by Rafał Wojciuk, and he implemented a special framework for Xen loadable modules, as he called it. So it was based on one interesting bug which was found in Xen by Rafał. This bug existed in the Flask module, and it allowed the DOM0 to escape to the hypervisor level. So there were many special hypercalls implemented with using this vulnerability. First of them was special hypercall for allocating some memory inside the context of the Xen hypervisor. And for example, one other hypercall was implemented to run arbitrary code inside this hypervisor. So we could use this framework to allocate a memory inside hypervisor context and run arbitrary code in it after overwriting its memory. And this is how we implemented a loader for Bluepill inside the DOM0. And to do that, we have to redesign a bit the memory management subsystem of the Xen Bluepill. So now it uses a single piece of memory for its code and data. It's actually pretty simple memory management. It just used in the beginning of the boot process of the Bluepill, in the beginning of initialization process. It just allocates a few memory blocks for VMCB structures or VMCS structures in case of Intel. And it's not used on any VM exit after. So I'll show you the demo of this attack. So this demo was recorded using a SSH connection to the vulnerable host. You see the shell, which we on a vulnerable host, and this is the DOM0. We run Xen detect just to be sure that Xen is active. The attack was targeted against Xen 3.2 system. We see that Xen runs one HVM domain, XP in this case, but currently the shell is in DOM0. So we execute the exploit code just to load this new version of XBP. And you see that actually it runs fine. So it's not really important how we use this bug, because the idea here is to illustrate that Xen Bluepill can be run at any moment on a running Xen hypervisor. We just have to be executed in the context of this hypervisor. So it doesn't really matter what bug we use to go to this level of privileges. So we run Bluepill, and after you see this line, your Xen has been Bluepilled, the system is moved to the nested virtualization state. So the original Xen hypervisor is not the primary hypervisor anymore, because Bluepill is the primary hypervisor right now. And we demonstrate that Bluepill is here by running a special bpnoc utility. This utility is very simple. It just executes CPU ID instruction with a certain magic value in one of the registers. And Bluepill intercepts CPU ID and returns another magic answer on a different register. So we can see that Bluepill is active. But you see that sometimes the magic answer is 0. So that means that not all the CPU cores have been subverted. We subvert only one core, but it's not really a problem, because we can use the same vulnerability to install Bluepill on a different core if we just happen to run on a different CPU. So we can execute this exploit a few times, and we just have to know the CPU number that we are currently executing on. And when we have this CPU number is differently than the original CPU number which we used to run the first Bluepill, then we are sure that we are running on a different core, so that we can subvert it also. So this is a hardware virtual machine domain, HVM domain, which runs XP. So obviously it's not power virtualized. And you see that nested virtualization really works, because this HVM guest is not a guest of the Bluepill, it's a guest of its nested hypervisor, Xen in this case. And by the way, if you run this bpnoc utility inside this HVM guest, it still will return this magic answer, because there is no difference between two virtual machines. Like first virtual machine is the Xen hypervisor, and another virtual machine is its client, HVM guest XP in this case. So we can run CPU ID in XP, and it will return this magic value too. So we can control the behavior of every guest which runs in the system, not only the nested hypervisor, but all its guests too. If we have Xen 3.3, then we need to use some exploit to bypass its protection, its memory protection, which was introduced in 3.3. I mean the VTD extension. As we demonstrated, the Q35 chipset exploit on Black Hat, it worked quite well, but it's a different topic for discussion. So how could we detect a Bluepilled Xen? So obviously we cannot use a detection for any VMM running, because of course we have virtual machine manager running, and it is Xen manager. But the question is, how can we detect that this Xen hypervisor is not a primary hypervisor anymore, and we have some malicious hypervisor above it? So one idea is to use a timing analysis to see the time that takes certain VM exits to execute. Because, of course, if you have a stack of hypervisors, then it will take much more time to service any VM exit, because the information about this VM exit should pass through all the hypervisors that are involved. Let's start with impact on paravirtualized domains. For example, domain 0 in case of Fedora 8, for example. So the impact is 0 because there are no actual VM exits on paravirtual domains by the definition, because every virtual domains, any paravirtual domains, any paravirtual domain will generate a general protection fault if the CPU encounters instruction like vmrun, for example, because vmrun instruction is a privileged instruction, and paravirtual domain kernel does not run on the most privileged level, so it will generate a general protection fault, not a VM exit. So adding another hypervisor will not introduce any performance impact in this case, but on AMD, of course, because on Intel we have obligatory intercepts like CPU ID, INVD, and move to and from CR3 register. So this instruction, like CPU ID instruction, is not privileged, so we can run it in paravirtual domain, and still it will generate some. It will introduce some performance impact because we have a stack of hypervisors enabled. So what about hardware virtual machine domains? This is a picture that illustrates the impact on HVM domains if we use full nested virtualization and some other variations of this algorithm of nested virtualization. Let's say these are just some optimizations that we tried to implement just to see how far can we go to minimize the performance impact. For example, as I said earlier, we need to use CLGI, STGI, and vmload, vmsave intersection just to be sure that no problem will happen when a nested hypervisor will get the information from its guest state and so on. And it turned out that in case of Xen, we can safely discard these interceptions. So we don't take any, we do not service any of these interceptions, and still Xen hypervisor works well. This is good because it allows us to minimize the performance impact to as low as 2,000 CPU cycles, because original Xen takes, for example, 5,000 of cycles to service typical VM exit, like CPU ID, let's say, and Bluepilling the Xen takes 7,000 cycles. So 2,000 cycles is added by the Bluepill. So this is how far we are from the Holy Grail or the invisible malware. Of course, you can observe this impact on hardware virtualized machine domain. You see zero performance impact on AMD paravirtualized domains. So this is very cool too. So a few words about another way of detection and prevention of the Bluepill. So not exactly prevention, detection. HyperGuard is a project run by Phoenix Technologies. It is supposed to run in SMM mode, system management mode, and it is supposed to check certain regions of physical memory from time to time.